Hello everybody, this is Karthikeyan from JCB. My topic is machine learning for intelligent authentication in 5G and beyond wireless networks. The subject was principles of artificial intelligence, fifth generation. Shortcut 5G and beyond wireless networks have received tremendous attention in both academia and industry alike, which enable a wide variety of vertical applications by connecting heterogeneous devices and machines. The dramatically growing number of low-cost devices and access points with increased mobility heterogeneity leads to the extremely complex and dynamic environment of sixth generation and beyond wireless networks. Specifically, due to the open broadcast nature of radio signal propagation, widely adopt standardized transformation protocols and intermittent communications, wireless communications are extremely vulnerable to interception and spoofing attacks. Challenges for existing physical layer authentication. Physical layer authentication has many advantages such as low computational requirement and network overhead, but it also faces many challenges. The main reason is that most of the existing physical layer authentication techniques rely on static mechanisms, while encountering the physical layer authentication has many advantages such as low computational requirements and network overhead, but also faces many challenges. The reason is that most of the existing physical layer authentication techniques rely on static mechanism while encountering the challenges to pre-design a precise authentication model for supporting new applications of generation and beyond wireless networks, complex and dynamic wireless environment of generation and beyond wireless networks. To be more specific, we summarize the challenges for existing physical layer authentication techniques as follows. Low reliability when using signal attribute, difficulty in pre-designing a precise authentication model, uh, impediment to continuous protection of legitimate devices, challenge of learning time varying attributes. Authentication in intelligence. So the low cost efficiency, high reliability, model independence, continuous protection and situation awareness are in the authentication of intelligence. Next one goes to parametric learning methods. So the family of parametric learning methods has become mature in literature as exemplified by logistic regression, linear decrement analysis, uh, perceptron, and naive Bayes, which requires a specific form of training functions. In the training function related to the training samples, example, the collection of multi-dimensional information are selected appropriately. The parametric learning methods could be more accurate, simpler, and required fewer training samples. Then the non-parametric learning methods. However, this kind of learning methods may be limited in 5G and beyond wireless communication scenarios wherein the static properties and a priori knowledge of attributes are not at hand. So coming to non-parametric methods. In contrast to parametric and non-parametric learning methods are not specified a priori but are determined from the available data. Examples included for kernel estimator, k-nearest neighbors, also known as KNN, and decision trees, to name just a few. A kernel machine-based scheme for an intelligent physical layer authentication. Non-parametric learning methods learn dynamically from time-varying environments without requiring any assumptions concerning the training models. However, compared to the parametric learning methods, they require more training data and may vary in overfitting. Supervised learning algorithms. The main difference between supervised and unsupervised learning algorithm is that supervised learning requires a priori language of outputs for corresponding inputs, while unsupervised do not need labeled outputs. Some supervised machine learning algorithms are studied in for defending against false data injection attacks, such as perceptron, k-nearest neighbor, support vector machines, etc. So coming to the conclusion, the intelligent authentication design is developed to enhance security performance in fifth generation and beyond wireless networks. The machine learning paradigms for intelligent authentication are classified into parametric and non-parametric learning methods as well as supervised and unsupervised and reinforcement learning techniques. As a conclusion, machine learning techniques provide a new sight into authentication under unknown network conditions and unpredictable dynamics, and bring intelligence to security management to achieve cost-effective, more reliable, model-free, continuous, and situation-aware authentication. Thank you.